Okay, we want to extend this solutions to linear equations into the function realm, where we have functions that are equal to each other. We can think about these things the same way we think about solving linear equations, and it's actually an extension that we can even go beyond linear functions into all sorts of functions. And it is useful a lot of times to find out when are two functions equal to each other. You know, at what point are those two things the same? So let's go ahead and just do this problem, and then we can talk about some extensions that can be done. Okay, so f of x is equal to 3x minus 2. So let me just go ahead and graph that. So when x is equal to 0, that would go away, and I just have the function value at 0 would be negative 2. And then when x is equal to 1, it's going to be adding 3 to it. So each time I add 1, it's going to add another 3. So the slope of the line, or the rate of change, is considered 3. So it's going to go something like that. And then the function g of x, it graphs out, let's see, when g of 0, so when the function value at x equals 0, that goes away and I just get 5. So something like that, and then it's going to go down by a half as the rate of change. So it looks like it might cross somewhere around 2, right? That's my guess. So let's go ahead and set those two things equal to each other. We can use the substitution method here. We can say, well, f of x is equal to that, and g of x is equal to that. So if I substitute those two expressions in for f and g, it would be just like this. 3x minus 2 is equal to g of x is minus 1/2 x plus 5. And then if I solve this for x, that would tell me the x value when f of x is equal to g of x, right? So I'm going to add 1/2 x to both sides. So we get 3.5 x's, and then I'm going to subtract, or no, add 2, right, to get rid of it there. Add 2 there, I get 7, and then I'll divide by 3.5, and actually 3.5 goes into 7 evenly twice, right? Well, if I didn't know that, let me change this to an improper fraction. So this would be 7 divided by 6 plus 1 is 7 halves. Right, 3.5 is an equivalent fraction to 7 halves. And then to do division, I would multiply by the reciprocal. So 7 times 2 over 7. And then you see that 7 divided by 7 is 1. So I would get x is equal to 2. So that is the value of x when these two functions are equal at that point right there. So what is the function value when x is equal to 2? So f of 2 would be 3 times 2 minus 2, which is 6 minus 2, or 4. And let's just check to make sure that g of 2 is also 4. So negative 1/2 times 2 plus 5. So 2 divided by 2 is 1. So this is negative 1 times 1, which is negative 1, plus 4, or plus 5 is also 4. So that checks out. That's my check step. So what it means is that the two functions are equal to each other when your x value is equal to 2. Right? So you can look at other functions, and they could be curvy things like this. And wherever those intersection points are at, so let's say this function, this curvy line right here represents f of x, and this straight line represents g of x. Here it has two solutions, right? When x is equal to, I don't know, if I gave some numbers to this, then I would say, well, f of x equals g of x when x equals 3 or 5. So this would have two solutions here. But all linear equations are only going to have one solution. Or they could have infinite number of solutions if it was the same line right on top of it. Alright, because all the values along both lines would be true. or it could have no solutions if the lines never intersected, right? If they were parallel lines. So the same thing is true of any function, and they can be curvy, or they could just be they could cross just a single time. If they were like that, that only crosses at one point. So it's possible that there could be multiple solutions as well with other types of functions. Okay.